A centrifugal compressor operates using the principles of dynamic displacement. Vapor is drawn into the center or eye of the rotating impeller. The velocity of the vapor at the eye of the impeller is negligible. As the impeller rotates, the vapor moves along the impeller blades outward, always away from the rotational axis. In the process of doing this, the velocity of the vapor increases as it gains kinetic energy. The vapor exits the impeller and passes through a diffuser, which reduces the vapor velocity. This process converts the kinetic energy of the vapor into pressure energy. The pressurized vapor is collected in a volute, where it is directed to the outlet of the compressor. The compression ratio for centrifugal compressors is somewhat limited, but they can support high refrigerant flow rates, so these compressors are widely used for large, steady loads. Centrifugal compressors are often employed for chilling water and air conditioning applications, but are rarely used in industrial refrigeration.
All centrifugal or dynamic compressors work by increasing the velocity of a vapor and then converting that velocity energy into pressure by slowing the vapor down. Let's walk through it on the whiteboard here. So what I've drawn here is a picture of an impeller, and that's what would be inside of a centrifugal compressor. The vapor enters the compressor at what's called the eye of the impeller, and that's indicated by that circle in the center. And when it enters, each one of those pink dots is representative of like a molecule of refrigerant vapor, okay? And that molecule is spinning, but since it's so close to the center or the eye of the impeller, it's not moving very fast in terms of any linear speed. But as that impeller spins, rotates over and over again at a high RPM, those molecules move up the vane of the impeller, and the speed of the vapor is increasing. And if you're still having trouble understanding this, I like to explain this to people maybe by using a demonstration of a yo-yo, which I happen to have right here. So I'm going to take my yo-yo here, and I've pinched it here about 3 inches from the yo-yo. And as I start to spin this at a constant speed, you can see the yo-yo is spinning around a circumference at the velocity that you see here. Now, as using this as the example, as it goes up the impeller, it's kind of like me extending this string to about right here and trying to spin at the same velocity. Now, to your naked eye, it might look I'm spinning at the same speed, or at least I'm trying to, but the yo-yo, the path it's traveling, because the circle is so much larger, is actually traveling at a much, much higher velocity, okay? Because it has to go that whole distance instead of just that small distance, a much higher velocity. So that's what happens here when the molecules go from the eye of the impeller to the end of the impeller, all right? So now we have this very high velocity vapor, but that's really not what we want. We want high pressure vapor. So how do we do that? Well, it leaves the impeller and enters what's called a diffuser, and the diffuser slows that vapor down. Okay, so we've added energy to the vapor by increasing this velocity, and by slowing it down now, we convert that energy from velocity energy into pressure energy. And then the final stage is just what's called volute casing, which is simply a way to direct the flow to where we want it to go. So that's just the exit of the compressor, is what it's called. And now our higher pressure vapor leaves the compressor. And that's how a centrifugal or dynamic compressor works.